All right, so we're going to talk very briefly about the requirements for inference for hypothesis tests. We're going to start with proportions. We'll do means a little bit later. So I know I don't always remember to do these when I remember to check conditions when I do my examples, but I try to. And I want you to try to remember to check that the requirements are met before you compute your hypothesis test, okay? Now, sometimes on a test, maybe I will have you do it anyway, but at the end there might be a question that says, hey, should you trust the results of your hypothesis test? And if the conditions weren't met, the answer is going to be no, you shouldn't, because central limit theorem doesn't really hold because the conditions weren't met. Maybe our sample wasn't random, so it's not representative, things like that. Even if it was random, it could still be not representative if it wasn't drawn from the appropriate population. So for proportions, we want to remember that our sample should be a random sample. And really by random sample, we mean that it needs to be representative. So again, I could totally take a random sample from, let's say, Clayton State students, but if I'm trying to do a hypothesis test testing a population of Georgia high school college students, Clayton State students are not really necessarily, they're not going to be representative for all college students in Georgia, right? So even though it's a random sample, it wasn't drawn from the correct population. So you've got to remember to check those sorts of things. Then we need to check to make sure that the conditions for the binomial are satisfied. That means a fixed number of trials, right? No picking dice from a bag until you get 6 green ones, right? No, you've got to set a number of trials beforehand. So n has to be a set number ahead of time. Your constant probabilities, right? You can't have the probability of a success changing as you draw your sample. So generally that means that you're sampling with replacement, or that your sample size is so large, much smaller than the population that even if you're not sampling with replacement, that the probabilities aren't changing enough to worry about. All right, so we'll write that sampling with replacement like we did with the dice in the bag, or n less than 10% of the population, so that we can ignore any small changes that might happen in those probabilities. We need 2 outcomes, right? We need something that counts as a success, something that counts as a failure, and our sample size needs to be large enough, right? We need to have 5 successes, 5 failures at least, right? 5 successes, 5 or more, 5 plus successes, 5 plus failures. And remember, failure, success, it's not a judgment call. It's just success is the outcome that you're counting, when you're taking your sample, and failure is pretty much everything else. And some books will say 10, some books will say 5. We're going with 5 for now. This is kind of up for discussion still in the statistics world. And so for means, we're going to talk about all this later, but that's your whole detailed list of requirements. The ones you should definitely be checking is that it's a random sample and that you have 5 successes and 5 failures. I don't think I ever throw at students anything where we don't have a fixed number of trials or that we're not sampling with replacement, and it's going to be an issue. So you really want to focus on the random sample, 5 successes, 5 failures.